Hi, my team and I are from the USGS, and we've been working on a project whereby analysis-ready data can be generated and made available in a manner that's findable, accessible, interoperable, and reusable. I'm Robin Fergason, and I'm a data user and often a data generator, and I work with a fantastic team. Jay Laura has led our software development efforts in STAC implementation. Mark Hunter is a metadata and data standards specialist, and Trent Hare is an expert on standards and data access. So this is the problem we're trying to address. In planetary science, data is typically publicly available as minimally processed image products, and the community then spends a significant effort processing this data for scientific use. In addition, data providers and data portals are trying to provide a solution, but they are also processing and storing these data at a significant cost to their projects. And each instrument has unique data processing steps, so it's a really steep learning curve that not only takes effort away from science investigation or developing a really sweet data portal, but it's also a significant barrier to individuals learning how to use new data sets. And this is disproportionately felt by those new to a field or a data set, or those who are new to or outside of the planetary community. So I have to wonder, how much effort is wasted on preparing data for analysis when instead we could collectively be using that energy for learning and scientific discovery? How are these factors impacting our ability to increase knowledge and understanding? So one model we've considered is data access in the terrestrial community. The terrestrial community has access to data that's ready for immediate analysis. And what I mean by that is that it's been calibrated, atmospherically corrected, geometrically projected, and tied to Earth's datum so that surface features are in the correct location. And there's often additionally higher processed data products available as well. Specific examples include Landsat and Sentinel-2. But there are important differences between terrestrial data and the planetary data, right? Including the more systematic nature of terrestrial data collection, say for Landsat, and the volumes of data that are produced by these instruments. But as planetary data volumes continue to increase, and with the current emphasis towards a more standardized data collection and interoperable data, we can look to the terrestrial community and learn from their experiences. And we expect that there will be an ever-increasing value to the availability of data that is pre-processed using standards and demonstrated methods that are well documented and trusted, and also the greater availability of higher-order data products. But furthermore, as data migrates to the cloud, we have an opportunity to make these data more accessible and more interoperable. So, we're trying to reduce the barrier to using planetary data by using our expertise to provide data and higher order products that are ready for immediate analysis, often called analysis-ready data. And we're using the SpatioTemporal Access Catalog, or STAC, to organize data in a very straightforward and standardized way. So our goal is not only to provide analysis-ready data to users, but we also want to provide a catalog of images that data portals and other services could directly ingest into the tools and services that they provide. These two goals, I think, will help reduce the significant redundant efforts that the community is exerting in processing planetary data. In addition, though, this approach is responsive to multiple findings and recommendations from the Planetary Data System Internal Review Board report. Specifically, Recommendation 49 states that NASA should fund the development of more analysis-ready data products derived from lower-level products created by NASA missions. And this also addresses Recommendations 40 and 41, which relate to making these higher-order data products systematically available and that comply with FAIR. And FAIR is making FAIR data principles are having data that's findable, accessible, interoperable, and reusable. So the method that we've selected for implementation is STAC. And our decision was heavily influenced by the fact that Landsat releases data using STAC and the fact that it's also really simple and straightforward to implement. We spent the last year and a half understanding the STAC standard and how to apply that terrestrial standard to planetary data. And these are the main parts of the STAC schema. First is a STAC item, and this is a pairing of a collection of data, which is also called an asset, and metadata. So the spatiotemporal asset is any file that represents information about a planetary body captured in a certain space and time, and the schema is raster focused as opposed to vector focused. This is often in the format of a cloud-optimized GeoTIFF image. The STAC item is a JSON file, and it provides all of the additional metadata to make it useful and it also has a link structure to where the catalog can ensure that search engines can crawl it, such as Google. And we've created an initial Planetary STAC extension and submitted this to the STAC group. And this is thanks to and based on a newly refactored PDS UPC schema, so there's some consistency there. So there's also a STAC catalog, and this provides links or items to other catalogs. And it's analogous to a folder in a file structure. It's the container that holds all of the items, but it can also hold other containers or other catalogs. And what we have on the right is a visualization of a catalog that we've developed, just rendered by one type of tool. Any tool can render a different visualization using the STAC specification, since it's just a JSON and a URL. But this is a catalog that has Kaguya TC-DTMs that we've generated using the NASA AIM stereo pipeline, just to give you kind of an idea of what one of these catalogs could look like. And for the really observant watcher today, you can see in the upper right corner that our kind of our base image, where you can locate where this data is of Earth. Because this is a terrestrial standard, that's one of the challenges that we've faced. But we figured out a way to manually change that, and we've added an issue to the STAC repo to see if we can get that to be a standardized way that you can look at STAC catalogs with the STAC browser. So what does STAC enable? What is the benefit of having yet another standard or catalog? Well, we think there's a lot of benefits to STAC. First, it provides a direct means to access the individual image products generated, and not simply mosaics. And this is particularly beneficial for controlled image data. The standard has a raster focus, but it's not just for visible images. It works for any spatial data set. For example, DTMs, thermal infrared images, spectral images, composition, etc. It's also really simple and straightforward to implement with a uniform method to index derived data catalogs. And it can complement the PDS archives and reference and link to the PDS image data source for these data derived products. So within the STAC JSON, the metadata file, you can actually link back to the raw data, the raw PDS data, where the derived products were derived from. So you can always keep that link back to the PDS if you choose to. It also exposes image metadata to search engines. So for example, the product IDs can be indexed by Google. And it also supports the compatibility with FGDC and ISO metadata standards, which gives us greater access to the growing ecosystems of both terrestrial and planetary spatial data tools. Both of these factors could have an impact on our ability to discover and use new data. And it also provides external real-time access to data. So no database or map servers needed. Or users can also download the data locally for use. But having these images and this STAC provide data in a cloud-based environment has implications for data storage requirements. If you don't have to download data, you also don't have to have these large servers at your access. And it also then lowers the bar for accessibility and the use of planetary data by a wider range of users. So the first prototype we tested was whether the terrestrial STAC schema could be successfully applied to planetary data. And this catalog, along with the catalog that was shown a few slides ago, demonstrates a successful implementation of the STAC schema to these data using our planetary extension. So these data specifically are Galileo and Voyager data of Europa that result from the generation of a control network and updated instrument kernels through a project led at the USGS by Mike Bland and Lynn Weller. In the past, when the USGS generates a control network, we've released a controlled mosaic and then the updated kernels. But with STAC, we can very easily also release the individual images that are projected using the updated image pointing kernels. And we feel this is a huge benefit because previously, if you wanted to use individual images that had been in the control network, you had to know the images, you had to know which kernels were updated and were supposed to be used, and you had to know how to process those data from raw data all the way to the controlled state. With this implementation, we can provide these images that have already been controlled, already projected using that new controlled state. And in this case, for the Europa community, I think this is really beneficial because the original SPICE for many of these images is very poor. So the pre-processing of these data is even more challenging. And we recognize that in order to make a catalog like this useful for individuals, we have to improve our search capabilities. Right now, we've been focusing on just understanding whether or not this implementation will work for planetary data. And our next step and the subject of current efforts is improving the search. So the second implementation focuses on a really simple data discovery method as a technology demonstration. So say you don't want to search through a data catalog to locate the images of interest. The images live in the cloud, so why can't you just directly stream them to your favorite GIS? Well, you can. You can ingest images directly from the STAC catalog into like ArcGIS Pro or QGIS. But in addition, the video clip that I'm showing on loop demonstrates a prototype QGIS plugin that queries a STAC-compliant catalog of Themis infrared images from Mars using Elasticsearch, and it's based on the user defining a location of interest. So if you notice, there's going to be a red box drawn here. So the user's drawn a box, a region of interest, and then it can import any image in the STAC catalog that intersects that box. So this eliminates the need for the user to process the data, also to even identify the data or download the data onto so I think that's a really huge benefit. You don't even have to do a search or identify data. Any data that would be in the catalog would be available to you. And then once it's in a GIS, you can continue to analyze the data as you normally would. And an application like this, though, I think is useful if you have a specific region of interest and would like the data available over that region. One challenge we face is that there's a wide variety of users across the community, and to allow users to address the questions they're working to answer, we need to enable data discovery over a wide range of variables, not just spatial or temporal searches. And a better understanding of these user needs is also an ongoing effort. So some potential use cases include a QGIS or ArcGIS Pro plugin that will stream data directly to the application. And you've seen this in the previous slide. But data portals could also stream data directly from the STAC servers. And examples on the right include two popular and very well done data portals. Portals could provide users with another means by which to visualize and manipulate data in an application that they're already really familiar with, but by streaming data from the STAC server, these portals could reduce their burden of processing data. So those data processing efforts could then be transferred to providing for perhaps a greater functionality to their portals. And finally, a STAC catalog does still support the direct search and navigation of data that's contained in the catalog, and this is a data discovery and search method that's already very familiar to the community. So these efforts of providing data in a format that's analysis ready is just one method that's responsive to the PDE IRB findings and recommendations, and it also follows fair practices where data is findable, accessible, interoperable, and reusable. So thank you very much for your time today. If you have any questions, we would love to hear from you and we would love to talk to you more. I've included here the contact information for myself and for J. Laura, but anybody on this team would be more than happy to engage with you and answer your questions. Thank you very, very much for your time.